Hello students, welcome to part C of my class. Uh, Students, we have been discussing that nuclear forces can be of the exchange force type just as electromagnetic and gravitational field. So, and Yukawa was actually the first one who came across this idea. He proposed that yes, nuclear interaction as we call them between two nucleons is by exchange of a particle, and he hypothesized that there is a particle called a meson, and the weight of the meson, the mass of the meson that he had predicted was about 270 times that of the mass of the electron. So it was like this. So that means it's quite heavy in comparison with the electron, and this theory, this hypothesis was later found to be true because something called the pion was discovered, and it had exactly the same mass as predicted by Yukawa. So let's see how things happen according to Yukawa. So what we are going to look at now is the Yukawa's meson theory. So according to this theory, all nucleons means what? Both protons and neutrons consists of identical cores. That means the central portion is the same. Cores which are identical, and they are surrounded by cloud of meson. So, and these mesons, they may be of three types. Mesons, or although he called them mesons, meson later on came to represent a large number of particles. Later on you will come to know about the pi meson, the mu meson, the nu meson, like this. But now, at that time, there was only meson known, which was the pion or the pion, like this, or the pi meson. They all stand for the same particle actually. So mesons are of three types. So three types, they are pi plus, pi neutral, and pi minus. That is negatively charged, positively charged, and neutral, like this. Now difference between the neutron and the proton only comes out with the cloud surrounding it. That means the central portion is almost the same. Not almost, it's the same actually, like this. So you look at this, let's look at this relation, things will be clearer. Proton is a positively charged particle, and the nuclear reaction actually goes this way, is equal to this. So look at this. A proton, when it, or I can say the neutron, breaks up into a proton, giving rise to a pi meson. Similarly, this plus this gives rise to this. Now let us look at this three type of reaction. So this is what proton and a neutron. So I can say this is a Pn and the Np kind of a force. That means they react with each other with this kind of reaction. And how does a proton act with another proton P dash? So in that case, what happens? You have P is P dash plus pi naught. We will understand these things properly when we go to a third unit, that is nuclear reactions. This is neutron, this is the Nn. Nn, that means the force between the nuclear force between the neutron goes this way, N dash plus pi naught. So you see what's happening here. That means for a proton or a neutron interaction, what is involved is a neutral pion here. See, this is the neutral pion out here, and for the others we have the positive and the negative ones. Here we have the negative, here we have the positive, and it's just, that means it's as if there is always a exchange. That means inside the nucleus, as I have already told I think in my first class, that a proton inside the nucleus does not for its whole life remain a proton, neither does a neutron remain a neutron. What happens is that they continuously change their states. You can also say that since the central part is the same, and if I have like this pi plus, pi plus, this will obviously be the proton. And if I have a central same core with pi neutral, what is this? This is the cloud that Yukawa has been telling about. So this is his theory, and this was found to be true somewhat, but later on, with discovery of more elementary particles, this thing did not actually stand, but can be used for to explain many observations. So this is the Yukawa's meson theory. We will learn more about it. We are doing only the preliminary things out here. So now we go to something very important, which is the idea of binding energy. So binding energy of a nucleus. Let's see what it is. Students, let us consider a nucleus. Let us name it like this. Let us consider a certain element X, like this, A, Z. So the very symbol like this obviously tells us that there are Z protons and there are Z is the number of protons and A minus Z is the number of neutrons. So how, if I break this, I will have Z protons and A minus Z neutrons. As a result, I should be able to write the total mass like this. Mass of the constituents of the nucleus as like this. The constituents I must be able to write as Z into mp, obviously mp is the mass of a proton, plus A minus Z, mass of the neutron, mass of the constituents of the atom. If I talk about the whole atom and not just the nucleus, then this will also have Z, mass of the electron, because if Z is the number of protons, we will also have Z electrons. So this is like this. So we can write it as, this is equal to Z, mass of proton, plus mass of electron, plus A minus Z, mass of the neutron. So I added up this and this, and students, I think we all know what is the mass of the, look at the hydrogen atom. Hydrogen atom has a proton in the center and an electron revolving around it. So what would be the total mass of the hydrogen atom? Will it not be mp plus me? Obviously it would be like that, and so I represent mp plus me as mh. Let's write it as capital M H plus A minus Z into M into N. So students, let's see what is this sum. This is the sum of the element that we had taken, and here we have taken also the electrons. So we are actually talking about the constituents of the whole atom. So it has got the electrons, the protons and the neutrons. When I add them, this is the formula. But then if the mass of this particular atom is measured and I denote it with by M A Z, wait, let me find some space here. So mass of the atom that we had taken. Suppose we have some device, actually we have devices, some indirect methods which we'll learn how to find the mass of an atom. So the mass of the atom, let it be equal to M A Z. It's found that this one is not equal to this one. It is found that the mass of the constituents is greater than the mass of the atom. So that means this is lesser. It is as if the constituents, the protons, the neutrons, and they all combined and some of the mass has been lost. And this quantity is said to be the binding energy or the mass loss in fact. So this is the mass difference or mass defect. So mass defect is ZMH plus A minus Z into Mn minus AMZ. So we stop here today. This is the mass defect.